Hello and welcome, ladies and gentlemen, to another lesson. Today we're going to be talking about synthetic division. I got it right here, synthetic division. All right. So I know this looks really gross. We got a lot of stuff on here, but actually this will be really simple, I promise. So last lesson we talked about polynomial long division, and so what synthetic division is it allows us to divide polynomials, and I just think it's much easier. So I want to show you guys this. There's one condition that we must satisfy when we're going to do synthetic division. That's why I got all these written out, so we can go through and say which ones we could use synthetic division for and which ones we could not use synthetic division for. So when can we do it? We can do synthetic division when we have something, whatever our polynomial is, divided by x or any variable plus or minus some number. Well, any number, okay? So whatever this is, that's an underline. So whatever that number is. So if we were to look at these ones and go, which ones can we and which ones can we not do synthetic division for, we would say that we could not do it for this guy because we have an x, but we don't have a plus or minus anything. If we were to look at this one, we could do it because we have something divided by x, okay, x plus 3, just like this guy. So this fits what we need. Now, going down to this one, so here I'll put a little check by that guy. We can do synthetic division for this one. If we move down to this one, we have divided by x squared plus x. So when we're going to do synthetic division, we need x to the first power, or whatever our variable is, we need it to be to the first power. So because this is to the second power, we cannot do this one. Now, if we go down to our next one, we have divided by x minus 5, which is good because we have x to the first power right here, and then we have a minus 5. So this one, we could do it. Put a little check mark over here. Now moving down to this one, x plus 15. Hopefully you guys can start to see the pattern now. We can do that guy. Now this one has an n, but like we said, it can be any variable to the first power, and we know that this is to the first because there's nothing there to tell us that it's not, and it's minus 4, which is minus some number. So we could do this one. And then now, if we look at this guy, kind of like our top one, there's an n, but there's two problems here. It's to the second power, we need it to the first power, and then also it doesn't have a plus or minus anything, just like our top one. So we could not do synthetic division for this guy. So now what we're going to do, I'm going to do a couple problems through long division, or we're going to do 4 problems today. I'm going to do 2 of them long division, then we're going to synthetically divide them so you can see how, just how they are compared, how they're similar and how they're different. And then we're going to do 2 just synthetically dividing so we can talk about remainders and good stuff like that. So our first problem that we want to do, and we're going to do this with long division first, 2x squared plus x minus 10 divided by x, what do I have here, minus 2. Perfect. So, just like our last video, we're going to set this up in long division form. If you guys don't remember what this looks like, you can hop back to those videos, talk about it more in depth. So, we got our 4 steps. We're going to do 2x squared divided by x. I know that that is 2x. Then we're going to multiply both these. 2x times x is 2x squared. And then we have 2x times a negative 2, which is minus 4x. Throw our parentheses on it, subtract this guy, these guys will cancel, and then we have a positive x minus a negative 4x, so we're actually adding, we're left with 5x minus 10. We look at our 5x, we divide it by x, we're left with a positive 5 that we'll throw up here. We multiply, we go 5 times x gives us 5x, and then we do 5 times negative 2 gives us negative 10. Throw our parentheses on here, subtract it, and now we have 5x minus 5x, this will cancel, and we have negative 10 minus a negative 10, so we're adding that, and this 2 will also cancel. So our answer to this problem, and I'll put it over here so that we don't forget it, is 2x plus 5. So now what I'm going to show you guys is how to do the same problem using synthetic division. Now, I think synthetic division is way easier, but if you guys get a problem like this where it's set up where we can do synthetic division, you can do it either way, but I think this is easier. So this is when we're synthetically dividing, we are always going to have this. This is our setup. We're going to put this little, half square. If you want to make it a whole box, you can do that. We're going to have something up here. We're going to put a number in there. We're going to have a plus sign. We're going to have a 0, and then we're going to have like where we're adding. So the number that's going to go in our box up here, or if you don't have the box, our little half a box, the number that's going to go up here is the opposite of whatever is in our divisor. So we have right here, we have an x minus 2. So the opposite of a negative 2 is a positive 2. So we have positive 2 here. Now the way that we're going to fill out the rest of this problem is by looking at the coefficients of each term. There's like an invisible 1 here, and then a negative 10. So if you guys remember with the quadratic formula, we labeled these with a, b, and c. So like our x squared, this 2 would be our a, 1 would be our b, negative 10 would be our c. So in a similar way, we're going to take those numbers and we're going to put them in the same row as our plus 2 that we just put here. So we have a 2, we want to leave a little space. We're going to put a 1, and then we're going to put a negative 10. So now we're set up and we're ready to do our synthetic division. The first step that we're going to do is we're going to add down in this column. So we're going to go 2 plus 0. That's why we put this plus here. We're going to do a lot of addition, so that's why we got this guy here. So we have 2 plus 0 gives us 2. Our next step is we're going to multiply. We're going to take whatever number's on our box, and we're going to multiply whatever we just added to. So if we do, we're going to move it to here. So we're going to go 2 times 2, and it's going to go right here, which 2 times 2 is 4. So now we're going to add this column. So we went add, multiply. Now we're going to add again. 1 plus 4 is 5. Now we're going to move this to right here. My arrow's a little longer than I would have liked, but that's fine. We go 2 times 5, because we're taking our number that's up here, multiplying it by whatever's there, and we get a positive 10. Now we add a negative 10 plus 10, which will give us 0. So when we set up this top row, this was our number that came from our divisor, and these three numbers came from the coefficients of each term, positive 2, positive 1, and a negative 10. So our positive 2 came from our x squared term, our positive 1 came from our x term, and our negative 10 came from our constant term, or our term that doesn't have an x on it, okay? So now this down here, what's down here, this 2, this 5, and this 0, this is our answer. So if you remember, our answer when we did long division was 2x plus 5. So the one tricky thing about this is that when we add in our columns for our variables, so this is x squared, but this is not going to be x squared. This is actually going to be x. And so our columns shift 1 to the left. So our x squared would shift here. There's nothing there, so we're not left with any x squareds. Our x shifts left to this column, and our 2 is here. So when we write our answer, we're going to have 2x. And then we have our 5, and this is now our constant because it shifted 1 column to the left, and it's a positive 5, so we're going to put plus 5. And then this number would be our remainder, but we don't have a remainder for this one. And so if you look, this was our answer when we long divided, and this is our answer now that we've synthetically divided. So as you can see, we get the same answer. We're going to do a couple more, so if there was any part of this that was confusing, that's okay. I'm going to go through all the steps a couple more times. Okay, for our next one, we're going to long divide this one first, and then we're going to synthetically divide it, just so you guys can see one more time how they are the same. So we have 3x squared plus 2x minus 43. I know it's a big number, it's gross, but it'll work out, I promise. And then we're dividing it by x plus 4. So if we're doing our long division, we set it up just like our last video. We have 3x squared plus 2x minus 43 divided by x plus 4. We do our division here, we get 3x, and then we multiply, we get 3x squared, and then we get a positive 12x. Throw our parentheses on there, subtract it, this will cancel, and then we have 2x minus 12x, which gives us negative 10x. We drop down what's left, we have minus 43. We then multiply this guy, we go negative 10, which will give us negative 10x when we multiply, negative 10 times x, negative 10, and then negative 10 times positive 4 give us negative 40. So now we throw parentheses around this guy, we subtract it. Negative 10x minus 10x is like adding 10x, so this cancels, and then we have a negative 43 minus a negative 40. So again, this is like adding, so we have negative 43 plus 40 really, which is going to give us negative 3. So if you guys remember from the last video, our answer, when we write it, I'm going to write it up here again so we don't forget it. We put whatever's on top, and then we put our remainder, so this case minus 3, and then we put it over the top of our divisor, so x plus 4. So this is our answer when we long divide. And now we're going to synthetically divide, and hopefully, if I don't mess up my math, we will get the same answer. So just like the last one, our setup is we always have this. This is our setup. Again, if you want to make this a box, that's perfectly fine, but you don't have to. So reminder, what number goes up here is going to be the opposite of our number in our term. in our divisor. So this is a positive 4. So we're going to throw a negative 4 up here. And then just like the last time, we want to look at our coefficients, positive 3, positive 2, negative 43, and we want to throw them into this row. Okay, and so now, just like last time, we're going to do this addition. 3 plus 0 is 3. We're going to do 3 times a negative 4, because we're doing this, multiply whatever's in our top box up here. We get negative 12, 2, now we're doing an addition again, 2 plus negative 12 gives us negative 10. Now we're doing our multiplication again to get us to here. We have negative 10 times negative 4, and we have, so negative 10 times negative 4, again we're multiplying by what's up here. That gives us a positive 40. So what we're left with, negative 43 plus 40 gives us, negative 3. So negative 43 plus 40 gives us negative 3. And so again, like last time, we took this 3 from our x squared term, we took this 2 from our x term, and we took this negative 43 from our constant term. So for our answer down here, we're looking at our rows, or excuse me, our columns are shifting one. So this x squared would move to here, there's a 0, so there's nothing left. Our x is going to move to here, our constant is going to move 1 over, and like we said last time, this, whatever's left in this very far right column, is going to be our remainder. So we have 3x minus 10. Remember, our constant doesn't have any x terms on it. And then we have our remainder, which, just like we did with our long division, we're going to write our remainder, and then we're going to put it all over. And actually, that looks really bad. You don't want to write it like that. So we have minus 3 over our divisor, which is x plus 4. And you can either look at this original problem and remember it's x plus 4, or if you remember that this is the opposite of what's in there, that's another way you can do it. But you'll see when we do our answer this way, when we synthetically divide, our answer is 3x minus 10 minus 3 over x plus 4. And when we long divided, we got 3x minus 10 minus 3 over x plus 4. So you can see we got the same thing. Now, there's one trick that'll probably catch you guys off guard, and I want to make sure we go over it in case you ever get a problem like this. So we're going to do 2x cubed, and that's different, but we'll talk about that, minus 12x minus 18, all of that divided by x minus 3. So this one, I'm not going to long divide for you guys. We'll just go straight into synthetic division. So again, our starting, like whenever we synthetically divide, we have this for our start. What goes up in here in this box is going to be the opposite of our negative 3. So it's going to be a positive 3. And now, this is where it gets a little tricky. So we're going to take our coefficients, just like we did last time. But the part that's different about this is that you'll notice we have an x cubed, we have an x, and we have a constant, or a term without an x. So the part that's tricky about this is that we'll write our 2 just like normal. That's our first one. But we need to leave a column for our x squared. Now, so this is our x cubed. We got this from our x cubed, 2x cubed, right? And so now we need to make sure that we reserve a column for our x squared. So if we look at our dividend, what we are dividing, there's no x squared term anywhere. That means that we need to put a 0 in this column that would be for our x squared. So now we just go on like normal. So we go from x squared to x, and we get a negative 12 from that guy. And then we go to our constant, where we get a negative 18. So now we're just going to do the same process like we have. We're going to add here, get 2. 2 times 3 gives us 6. We add down, we get 6. We have 3 times 6. It's going to give us 18. We add negative 12 and positive 18. That's going to give us another positive 6. Then we multiply again, 6 times 3, and we get this positive 18. So when we add these, we're left with no remainder. So just like the ones we did before, we're shifting our terms over one column. So our x cubed would move to here. There's 0 there, right? There's like this invisible 0. You don't have to write that. So there's like 0 x cubed. Again, you don't have to write that. Our x squared column, here I'm going to label these columns. Our x squared column moved left one. This is our x squared. Our x moved left. Our constant moved left. And this, what's left here, nothing, okay? There's nothing for it to shift from, so it's just our remainder. So if we were to write our answer, we have the 0x cubed, which like I said, you don't have to include that if you don't want. But then we have a positive 2x squared plus 6x plus 6. And then our remainder, there's no remainder, so again, there's like this invisible plus 0 out here, but you don't have to do that. So our answer, if you were to write it without all the goofy zeros, would look like this. And again, you don't need that positive there, but positive 2x plus 6x plus 6. And if you wanted to long divide this problem, you could, and you would get the same answer. But we didn't practice that when we went over long division, so I'm just going to leave it. So we're going to do one more like this, and then you guys will be good to go. I'm going to post another short video on synthetic division with a couple other examples, just like I did with polynomial long division, so that you guys, if you're either feeling like you only need a couple examples to figure this out, or maybe you watch this whole video and you're still not quite sure what's going on, you can hop over to that video. I'm hoping it'll be 10 minutes or less, and you guys can get some more practice there. So our problem now, 3x cubed plus 4x minus 8 divided by x minus 1. So again, we're going to just synthetically divide. We want to start with our same setup. Again, whenever we're synthetically dividing, we need these like 4 things. We'd say that this box is 1, this addition sign is 1, the 0 is 1, and then our line here is also 1. So these 4 things we need no matter what when we're synthetically dividing. So what's going to go up here? Again, it's going to be the opposite of whatever this term is. So this was a minus or a negative 1, so we're going to do positive 1. And then now, again, we're going to look at our terms. And this one, just like the last one, you need to be careful. So we're starting with a 3, and this is our x cubed column. Again, there's not going to be an x squared. So we need to make sure to leave a 0 for our x squared column. Now we're going to go just down the line like normal. We have a positive 4 for our x, and we have a negative 8 for our constant. So now we're just going to go through the steps of synthetic division again. We're going to add down, gives us positive 3. We're going to do whatever we get when we add, multiplied by the number up here in the box, gives us 3. We have 0 plus 3 again, gives us another 3. We're going to, start over. So we added, we multiplied, we added. I just want to make sure to get the arrows for you guys because when we went over this in class, it was a confusing bit. So we added, we multiplied to here, 3 times 1 gives us 3. We're adding again down in this column, 0 plus 3 is 3. Now we're going to multiply, 3 times 1 again is 1. So now we're going to have 4 plus 3. We're going to add down this column, gives us a positive 7. Multiply one more time, we get 7 times 1, which is positive 7. And now we have a negative 8 plus 7, which will leave us with a negative 1. So just like our other 3 problems, our terms are shifting a column. So this would be our x cubed column, this would be our x squared column, our x column, and then our constant column. And again, our constants are our terms that don't have any x's or any variables on them. And then again, this far right row is for the remainder. So when we write this answer out, we'd have 3x squared plus 3x plus 7. And then again, we have this remainder here, so we need to make sure that we're going to put whatever our remainder is, minus 1, divided by our divisor. And like I said, there's a couple ways that you can remember what this divisor is. You can either look at the original problem, you can remember that this is the opposite of what our divisor is. So like we have a plus 1 here, so we know it's going to be x minus 1. However, whatever works for you guys. Awesome. Thanks for watching. I'll post another short video with a couple other examples of synthetic division for you guys if you need them. If not, that's fine too. Yeah, have a good day, and I'll see you guys in class.